right?
So again, if you were not moving with the ship and you were standing still with the photons, in the sense you weren't with the ship moving, you'd clearly see, yes, the photons are doing exactly what they're supposed to do, which is go from point A to point B in a straight line. So it's not even perception, it's perception from some human centric or from some human contrived perspective where, again, two simultaneous events happen, and because I move closer to one or closer to the other, that somehow now I have some notion that there might be some possibility that they're not simultaneous anymore, that they didn't really happen at the same time, that somehow I'm changing their reality because I'm in a different position.
Yeah, it's really funny. Some possibility that something might have happened. Yeah. Uh,
Looking at them, and it takes time for the light to get to me. I mean, it is such a bad theory. It's a concept that physics just should say no, no, no. Let's just no. Let's just say no. Just say no to bullshit. Equivalency is bullshit. Different forces affect things in different ways. A hammer is different than a tsunami, is different than a tiny force bits that could go right through objects and move them with tiny amount of interactions. I mean, X-rays are different than tsunamis, than hammers, than blowtorches, than blah 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 blah. Why play this game that it's all the same? All motion is not caused by the same event.
Different things entirely. The planet Earth is not accelerating upward.
Yeah, it is. Okay, technically. Okay, it is in the sense that if we say up and down, no matter what the orientation is, I mean, the basic point is, yeah, it's a valid statement, but it has to be valid in a context. Okay, that if there's an up, there's a down. And the simple argument is is that the Earth is sitting here. You stand on it on this side, okay, over here, and the other guy on the other side is standing on it over here. All right, I mostly see that. But the real point is that even without these people on here, the idea is there's a force heading in this way, and it's heading in all directions. So just assume this line is the same is true for every other line I could draw for up and down. So we're going to make left and right, up and down. I guess I could have just done it up and down, but fuck it. So what's really...
yeah, hold on. Yeah. Okay. It's really useful. The neurophone. Like, everything they've said, I'm gonna keep in my brain. Check that out.
happening is the forces coming in from both sides. Okay, the universe is pushing. All right, and the simple explanation is it's absorbing some of this, going this way, and it's absorbing some of this, going this way. So from this guy's perspective, this force is pushing him back up. This one can't be relevant, right? It's going the wrong way. It certainly can't affect him anymore. But this one, the one absorbed this way, can affect him in the sense that this piece of energy that was moving here, it was going for him. It was absorbed by the Earth. So now the Earth, pieces of the Earth are now moving this way. Okay, so pieces of the Earth, the ground below.
United States Navy. Yeah. That's exactly who the cabal would be. Holy shit. United States Navy. It's you. It's gotta be you. Or some. It's gotta be you.
Me is moving towards me. And the force, though, is hitting me in the head, okay? The whole force. And it's pushing me this way. So in a
You would look exactly like the guy that would be him. United States Navy. Yeah. Yeah. There was another movie that showed the evil guy, if you will, uh, the villain, and though he was in a submarine, and only somebody in the Navy would do this. And you're really, really old and perfect. What's your name? Desert File. I'm gonna check you out.
sense, the Earth is pushing you, and it's pushing you in both directions. The Earth is pushing you this way, the force of gravity is pushing you down, and you stay here. You don't go anywhere. And the same thing's happening to this guy with exactly the opposite dynamic. And the Earth has got a bunch of swirly hot stuff in the middle because of a consequence of this. This absorption and this absorption means this stuff, okay, is going to get hot because there's two opposite forces going opposite directions. It's being sheared and torn apart, heated, okay, by the very fact that it's got this happening in all these directions. All these directions, it has these two forces going opposite directions. So each pieces of it are going, this little piece ends up going this way. This little piece ends up going that way. All the pieces are being moved by an actual force, an actual pressure that's coming from the outside in. Push, 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 push. Pull is religion. Desert File. I'd like to. I wonder if Desert File would make a reply. I'll see if I can post. I'll post the link to my video and see if he replies. I mean, do you believe in their nonsense woo forces? I mean, there's no point in saying gravity is a force when you don't explain what a force is. I mean, What is a force? If a force can be invisible motivation, I'm motivated by magic. Okay, you're basically giving matter some kind of free will. You're giving little matter bits.
Yeah, that's exactly a mode that Cabal has used to classify things. So it's gotta be that guy. Jesus. Yeah, the Cabal is a military program that falls under the Unacknowledged Special Access Project program. And not even the President of the United States knows it. Uh, yeah, they've suppressed too many technologies from humanity. Like, I guess still getting my symptoms, but I'm not worried. I'm happy, really, right now. Because I know I'm gonna get it reversed this year. It's gonna happen. But yeah, so what most other people don't know, the neurophone goes into your permanent memory, whatever you have, like if you're hearing through your headphones like I am right now, or I have them broken, but you can also use the neurophone transducers. They're just two pieces of metal that same thing goes from the headphone to the output. It's the same because we can hear through the skin at a correct vibration, which that's another video. but we got that. We got Dr. Joe Wallach's health protocols. I mean, I did it correctly when I was young. I I could pass. I passed all the physical tests at MAPS military entrance processing site, and I passed also all the intellectual IQ tests, if you will, for my MOS, the SBAP, Armed Services Vocational Aptitude Battery. I still had the book, I think. So yeah, I was going to be a ground intelligence officer. I was under two people at that time, at that time known as Staff Sergeant Mancy and Staff Sergeant. Why can't I say that name? Staff Sergeant Mancy and Staff Sergeant Ortiz. There were others, but I forgot the name. They were my recruiters. It was at Plaza Las Americas, in Puerto Rico. I'm Puerto Rican. Check that out. I didn't mind going, as long as it meant doing the right thing. I didn't mind dying. I don't mind dying if it's doing the right thing. But I learned about all these things, like the extraterrestrials. I'm not gonna talk too much because I'm never gonna end. You have no idea. You have no idea. So this is what's going to happen. There was either way, yeah. So that's what I did. I improved my multiple sclerosis symptoms. And I passed all the tests I could. And yeah, I'm fine now. But it's like really easy for me to lose weight. I'm too healthy. Like you can't, the lightning will not let me show you all the veins. I look like I'm 90 years old in veins. Like, oh shit, I'm still all the way here. Cause you would see the vein like going here, and then goes here, over here into my arms. That's how healthy I am. But yeah, he says the truth. I learned a lot of things after my experience. But everyone seems to be ignoring him. And he's he's been correct so far. So far, he's been completely logical and correct. He's being actually even very careful with his choice of words. Listen to his words, not his mannerism. He's just, think of it like two outputs. Like low. If you've seen this video, lower the brightness. See, you lower the brightness and you won't see the screen. Just hear him out. That's it. That's all you gotta do. Don't look at him. Just hear. Okay?
It's some sort of will. In the matter bit, the geodesic sends a ESP signal that the space is bent. Why no? He's saying, no, there's no space. How can space be bent? I'm all alone here. No, it's bent. Trust me, it's bent. You now need to have the will to move. Oh, come on.
What direction again is up?
Einstein realized
Well, the opposite of down, so that's one way to figure it out.
that rather than gravity being a force acting at a distance that accelerates freely moving objects downward, we have to say that instead,
No, we have to say that. No, you don't have to do it. You don't have to buy this nonsense, okay? You have to go with your perception. You have to go with what you see. Something else moved and you don't feel that you're moving. Well, the fact that you don't feel it doesn't mean that you're not doing it. Right? I mean, we feel gravity, okay, when it's stopping, when we're being stopped, you know, and we don't feel it when we move the opposite force. Well, that sort of makes sense because I'm not being compressed by the opposite force anymore. There's no obstacle, so how can I feel the non-obstacle? Why would I feel an obstacle if there's no obstacle? Clearly we feel gravity when there's an obstacle that makes it visible. We can't see it if it doesn't hit anything, right?
gravity puts us in a non-inertial accelerated reference frame. And we have to say that the surface is what's being accelerated.
We don't have to say that. But of course it is. That's why we're not moving. That's why we're staying a certain distance from the center of the Earth. It's because there's a force pushing us back.
Upward.
No, Albert Einstein did not realize that, and we do not have to say Earth is accelerating upward.
Okay. So we'll just stick with the prescriptive part. That was the best part of this video, I would argue. So we'll go back to the other guy. Well, maybe we'll play the in-between, right? Okay. So he says experimental proof. So all he's using is a gravitometer or whatever, accelerometer, right? And so it's working on the same principle. There's just a little person in it on a string, so to speak, and you just move the object and you see if the person on a string moves, you know. So it really can't, it's only, again, comparing your inertial state in the sense of your state of being affected by gravity. The accelerometer can't eliminate gravity and give you an actual description of space, okay, the real description. It's stuck in the same thing. It has a perspective. The accelerometer has just as much a perspective that we have, okay? It gets hit from the bottom. It feels gravity when there's an obstacle to the gravity, and it doesn't feel it when there's no obstacle to it. So again, it's in the same condition. You can't flatten its ass with magic. You have to flatten its ass with a chair. So it doesn't prove anything. It's just changing the location of where you put the human. You just put the human in a different box and you're saying, well, here's exactly the same circumstances. There's a human inside a box with a chair. I'll call that an accelerometer. I mean, it's not a proof of anything. There's no elemental physics in this video. He's not going to give any elemental explanation. He's not going to explain why an electron and a proton sitting inside of us right now, okay, if the chair disappears and the floor disappears and I start falling into the center of the Earth, he's not going to give you an description of what's motivating the electrons and protons to move or the Earth to move past me. He's not going to give you an explanation for how they're moving and how their movement in absolute space, how they're moving in absolute space. There won't be any explanation for how it's possible to describe the Earth moving.
I've loaded my phone with an accelerometer app and attached it to a camera. Here are the axes of this setup.
So I'll give him some credit for trying to defend his mush in the sense that, okay, he's trying to do an experiment, great. I mean, he goes to the effort and the work to load the stupid app, which probably was annoying, and having the accelerometer and all this crap. But again, it doesn't demonstrate anything new. I could do this with a cat. I could do it with a mushroom. I mean, a bowl of Jell-O, okay, could suffice. I don't need an accelerometer to be able to create, like I said, liquids, for example, will show you. You can just watch what they're doing, and you can see they're not or are moving.
y, and z. When I accelerate the system in the positive direction along an axis, I get a positive acceleration reading in that direction.
Right, that's because the chair hit the ass. It doesn't demonstrate anything. You've met a force with a counter force. That's when the force is visible. The force is not visible unless there's some force acting against it. Then the force is hard to see. Okay, but it's easy to see if you understand, oh, it's just going with the flow of the force. It's being free to move along. Being free to move along, okay, is not disruptive. But clearly it is to human beings, because guess what? It takes a while for the force to get through us. So if we have a rocket engine and it's pushing you, again, I made these points. The astronaut is sitting down, lying down for a good reason, because if he was standing up, the acceleration would put in tremendous stress on his legs, because it's a smaller points that all the pressure has to go through, and all of your atoms have to be bang into each other to get the force through you. The rocket engine, unlike gravity, rocket engines aren't affecting each little atom in your body, where gravity is. Gravity is pushing on your atoms. It's not pushing on you, the physical big thing. It's pushing on the atoms. The littlest bits inside of you are getting pushed, each one of them. And so that force goes through you really efficiently, where a force pushing you in a rocket engine is incredibly inefficient. It takes a great deal of time for all of your bits to smash into each other, and all of that smashing is destructive. That's why you can't accelerate humans freely. You can't just accelerate them and, well, they don't feel anything. Of course they're going to feel something, because their body is going to start falling apart.
Sitting on a surface, it says that it's accelerating at 1g, 9.8 meters per second squared. Yet, unlike a car speeding up, it isn't going anywhere. Now let's see what happens.
So again, the fact that it's not going anywhere, just like us not going anywhere, doesn't mean we're not being acted on by forces. It just means the two forces, the one pushing me up, equals the one pushing me down.
When I drop it, it registers zero acceleration as it's falling.
So again, it just has nothing to do with measuring anything real, in the sense that it's just measuring merely because there's no chair, there's no scale. You're removing the scale, okay? I am weighing you, right? And then I remove the scale, okay? You don't really fall, because let's say the scale is really micro thin, all right? And I remove the scale. You tiny little jolt, maybe. You don't notice. Well, I don't even know how to say that. Regardless, the fact that the scale reads 0 when I'm not measuring you, right, isn't a big surprise. And that's all this is saying. It's saying, well, what are you reading? What's the scale say when I allow you to fall off the scale? There's no counter force. So it's not measuring the real force acting on the iPhone or whatever. There's no real force being measured here. The device is incapable of measuring the real force, because the only way it can measure a force is to have the force hit something. The detector has to be hit by it for it to measure it. If the detector moves, it can't measure the non-existent consequence.
Newton's second law of motion says that force equals mass times acceleration. So, if the acceleration measurement is 0, then any measurable forces acting on the phone must also...
Just terrible. Just terrible perversion of a mathematical equation, because it's not supposed to be done backwards. It's supposed to be done forward. Okay, so, again, the force acting on it, that equation is meant to measure things in one circumstance, when you have a known acceleration, a free acceleration, not when you're measuring two cars smashing into each other. You're not allowed to say there's no velocity where the two cars meet, right? There's zero velocity at the impact. So you're allowed to say, therefore, there's no mass, there's no velocity, no anything, so I could just make it 0. No, you have to account for what they were doing before they had 0 acceleration and zero velocity. You can't pretend they didn't have one before. And so when two forces interact, yes, there's zero motion. Doesn't mean that there's zero force. It means there's two forces. And gravity obviously has symmetry. There's just as much of it coming from the bottom. There's just as much pressure being absorbed, momentum going that way, as there is force hitting me this way. And the momentum going this way, pushing up, okay, came from where? Oh, that's right, the force of gravity on the other side of the Earth, pushing down, down from its perspective. But you can't say there's no force. You think there's no force in the center of the Earth? Is that what you would say? There's no force in the center of the Earth. I can go to the center of the Earth and there's no force. It's like the gravity example of the hollow Earth, right? And you get the idea that yes, you will be affected by no gravity. So here you are. There's matter on this side of you. You're right next to it, right? The crust. You're inside the Earth, right? And there's a roof, a ceiling around the whole thing. You're inside a ball, and you're right next to this hunk of mass. And then you're a little far away from the rest of this stuff. But anyway, it's mass right there. You can see it. And you're saying that, well, the gravitational force is a real thing. You know it. I mean, there's a real thing called gravity. So I have to be being affected by something. And the simple argument is, yeah, the massive amount of stuff out there is further away. So it's got a lot of mass, but it's far away. And the stuff right next to me has a little bit of mass, but it's really, really close. And those two things exactly equal. And so I am, in fact, being pulled towards this surface, but I'm also being pulled away, okay? Pulled in the sense of the inverse push. I'm both being pushed towards this surface and I'm being pushed towards that surface, and the two forces are equal and opposite. And Newton's equation wasn't meant to deal with equally and opposite forces that have been counteracted by being equal and opposite. It doesn't mean there's no force. It means there's no movement. I mean, it should be more explicitly stated that a moving force, a force that will cause movement, is what the real F stands for.
Be zero. Gravity must not be a force, but causes the phone to fall to the floor.
So again, he says this is a proof again. So pulling the scale out from under somebody and saying, look, it's read zero. No, that's not a proof. That the thing doesn't weigh anything. Anyway, so play something else. Play some of this Feynman stuff. All right, so this is the Zohar Kohevi. Yeah, there we go. Okay, there. Anyway, I don't agree with everything he says in this video. I'll leave a link below, and I've already played the Feynman clip, and first off, he's defending Lesage gravitational model, and Feynman is debunking essentially that model. But that model is a little bit incomplete in the sense that, it's just the basics of the model. It doesn't provide for charge and the other phenomena we see. And so I would say it needed to be improved as I've improved it. And so now it's a more viable explanation, clearly. And and again, it's not really Lesage gravity, it's Fadio gravity. And I don't know how much Lesage really improved on what Fadio had argued. But you can't really get too much of original papers and all that stuff, and it's in the wrong language and whatever. I don't know if Fadio came up with ultramundane particles, so that might have been something Lesage added. Obviously, Lesage did draw some images of it, so he made better illustrations of it. And I don't even know if I buy this argument that Newton hated it or something. No, Newton signed Fadio's paper, so he did, for some number of years, him and Fadio were in communication with each other, so clearly it wasn't until later that Newton concluded it doesn't work. So it's not like Newton didn't think about it. And they were making the same mistake, right? I mean, you see a fact and you say, well, there's an inconsistency, right? the idea of this particle field does destroy motion. It causes drag. And so you do have to explain how that drag is made irrelevant, how it's compensated for by actual mechanisms. And I've done some of that. But anyway, yeah, I don't necessarily agree with everything stated in this video.
This is, like 50 years ago, he won a Nobel Prize. And he actually is one of the very, very, very few people that I've seen talking about Lesage's theory of gravitation. So Lesage's theory is actually what I've been talking about in this channel mostly.
And yeah, then unfortunately, like, he never even called it that. He didn't even state that this is a 300-year-old counter argument to their relativity bent space physics, and that it does work quite perfectly to explain the functions that we see in gravity, and that its only flaw is this one regarding the resistance to velocity, in the sense that it would drag everything to a halt. If they, like I said, if you don't have a mechanism that explains why drag becomes irrelevant.
It's basically just a theory that was supposed to explain why gravity happened. Actually, Lesage came up with this theory like 300 years ago.
So again, it was Fadio who came up with it 300 years ago, and 200 years ago, Lesage, after Newton, somewhere after Newton, improved it. So Fadio was Newton's time, Lesage was after Newton.
And everyone just made fun of him for it, and pretty much no one accepted the theory. They talked shit about him behind his back. I think Isaac Newton just laughed at him behind his back.
So again, it says right here, laughed at Mr. Fadio's manner of explaining gravity. You know, that's Haley. Yeah, well, lots of them said it's got a problem. Okay, first they also didn't understand. You know, they were thinking of these things as being rocks, and that rocks hit things and rocks break into pieces and all of that kind of stuff. So they weren't really thinking of photons as indestructible pieces of momentum that might be absorbed. So another thing to understand is they had no concept of absorption. So this simple argument I've made of understanding that force gets trapped. Okay, that it can go into a system and be stuck in the system, that it can end up just going around in a circle. And as a force, as a thing moving, if it's caught in a circle that's for free, and it can just stay in that circle forever, obviously it's not getting where it's supposed to go. And they didn't really have a way of understanding that mechanism, that you could have this idea of the simple geometry could be made of something where, yes, you can turn right, and right can be up, or right can be that way, right can be different things in the 3 dimensions. So I'm just saying they had a very incomplete understanding, and they didn't recognize that this is a theory in an incomplete form, and that maybe if they work on it a little bit, they could complete it, and they just didn't want to. And instead, they stuck themselves to a theory they can never complete. You know, they chose one they'll never fix, which is the wooey bent space magical force theory. Instead of coming up with physical reasons why things happen, they kind of just, and again, it wasn't Newton's fault. He said, I don't know how gravity works. But he clearly did say it would be silly to think it's just some magical force. It just magically does it. There's got to be some physics. He just said, I don't know what the physics is.
And here's Euler just telling him he basically told him, like, your theory is kind of disgusting to me, it's repugnant, you know, and I'd rather just be ignorant and just tell everyone I have no idea how gravity works, rather than just going to that theory, and he calls it a strange theory. So yeah, there's that, you know, like, everybody who sees this theory seems to have just, like, be very skeptical of it, right? Maybe a little too skeptical. So anyways, here's Richard Feynman talking about it, and he actually does an extremely good job explaining everything.
Perhaps you've thought of it yourself. Every once in a while, some student comes running in and he suddenly explains gravity.
Right. Well, to those critics, I mean, it's obviously more than Fadio or Lesage could have thought of it. I mean, Lesage didn't think of it. He actually thought Fadio was correct and purchased the rights to Fadio's work and continued it after his death, essentially. But again, the idea that you have to come up with an accountable mechanism, a physical mechanism causing the effect, and the simple idea that everything is being pushed, that there is something in the universe, okay, this invisible photons, these pieces of photon, and that force is accounting for what you see in gravity. And then I argue simply that a magnet is just filtering that force, because the force does have two variants, an electron force and a proton force, and it accounts for charge. And if you just think of the charged particles essentially being filters, and when they're put in a dipole, they filter in a specific way, you can account for all of what they call fields. And you don't have to believe in antiparticles and entanglement and all kinds of the other woo. It's all completely unnecessary. You don't have to think of time as a dimension. None of that stuff has to happen. It's all just storytelling, and they're not good stories.
Suppose that in the world, everywhere, there are flying through us at very high speed a lot of particles that come equally in all directions. They're just shooting by, and once in a while hit us in a bombardment. But we and the sun are practically transparent for them, nearly. But some hit, and so it's not completely transparent. Then look what would happen. If the sun is here...
Well, the idea of complete transparency, you can't think of it in those terms, because the fact is that we already know that if you hit an electron, okay, so the point would be is you could possibly, theoretically, absorb all of the gravity force. And so it sort of argues against the idea of a infinite gravity well. The whole singularity thing goes out the window, that there is a finite amount of this pressure in the universe. So that's another consequence that nobody talks about. And it's sort of a debunk of this idea of infinite mass. You just can't do it. It's always going to be a finite well, so you don't run into any singularity problems and any notions of having to create a singularity. But the simple argument I was going to make was, the transparency argument. So the idea is that something will be made of a bunch of atoms, and the point is that gravity clearly acts as a nuclear force. If I just put one atom next to the Earth in orbit, it's going to move exactly in the same orbit as the Earth does. The sun's gravity will affect it exactly the same. It's velocity that determines your orbit. So it doesn't matter how big you are. It just matters what your velocity is. Velocity dictates where you orbit. Whether you're here or here or here or here. It's all just velocity. Mass is irrelevant. So if your velocity is right, that's where gravity is going to put you. So the Earth could be understood as just being a bunch of atoms that aren't even connected to each other. You could see it that way. And this force hits an object. Well, the point is that the force could be absorbed by this electron, and it gets hit by it and hit by it and hit by it and keeps accelerating. Well, it's going to accelerate into other electrons in the Earth. And so it's going to transfer the force, okay, by hitting the other electrons. So the momentum is what's really getting absorbed. So the momentum of the actual force could, in a sense, in some areas, be completely absorbed by the density of the Earth. But it wouldn't matter, because the force is constantly hitting anything moving slower than the speed of light. So all of the atom bits are being hit constantly by the force and being absorbed. So it's always essentially the same amount of force, and it's not really about transparency. It's just about the density of your atoms. And so that's why mass becomes relevant to how much gravity you can create. That is, how much of a shadow you cast on something else is going to be dictated by how many pieces of movable stuff there is inside of you. But the force itself, okay, is in effect just going to give pieces momentum. And obviously it's going to be doing it in both directions is the point. And, but whatever. And so you're essentially trapping this force moving the speed of light interacts with matter. The matter moves much slower, much less than the speed of light. And so the force doesn't get where it's going because it's stuck in here making the Earth hot. And it ends up getting eventually re-radiated through thermal equilibrium, you could argue, in all directions. But it's clearly irrelevant to this object. When you radiate it in this direction, it's clearly this can't have anything to do with this. So clearly, the only stuff that's going to matter is the stuff that's going to hit you or interact with you. And the bottom line is there's still going to be a low pressure here in terms of an absence of interaction between the two.
And the Earth is here. Then, if the sun weren't here, there would be particles bombarding from all sides, giving little impulses by the rattle of these bang-bang, the few that hit, which would not shake the Earth in any particular direction, because there is many coming from one side as the other, from top from bottom. However, when the sun is here, the particles which are coming in this direction are partly absorbed by the sun, because some of them hit the sun and don't go through. Therefore, the number that are coming from this direction toward the...
And move the atoms in the sun. Let's just recognize that you can't kill the momentum. You can only trap it.
The Earth is less than the number that are coming from the other side, because here they have no opposition from no sun there. And it's easy to see, after some mental effort, that the further the sun is away, the less in proportion of all of the particles are being taken out of the possible directions in which particles being...
Right, so he could say the darker the shadow, right? The further away, the weaker the shadow, the closer, the darker the shadow gets. Inverse square law. Same as a light bulb, same as lots of things that are, you don't think of photons as being bent geodesics, okay? They're obeying the inverse square law from a light bulb. Same mechanism, basically, and all you're saying is, all I'm suggesting to you is there's actually a lot more of those photons hitting us all the time. They're just invisible. The lights are on in the universe, more than just the light. Lights you see.
Smaller, and in fact inversely is the square of the distance. So there will therefore be an impulse toward the sun on the Earth that's inversely as the square of the distance, and is the result of large numbers of very simple operations, just hits. One after the...
Yes, hits, just pushes, push, push, push. Push makes sense, pull doesn't make any sense. Pull is not an elemental function, it's just useless as a description, it's just incoherent, frankly. It's physically incoherent as elemental function.
The other from all directions. And therefore the strangeness of the mathematical relation will be very much reduced, because the fundamental operation is much simpler than calculating the inverse of the square of the distance. This machine does the calculating.
So another shot at the notion that physics has to be math. Physics is a model. Their model is full of invisible magical functions. Fact. The model I'm suggesting is full of mechanical mechanisms with specific functions.
These particles bouncing.
wow, guys, that was just amazing, right? Like, he explained it pretty freaking good, you know? He set it up the way it needs to be set up, right? Yeah, let's keep watching.
Only trouble with it is that it doesn't work.
If you don't try. Yes, at first glance, you can find a problem. And then at second glance, maybe you can alleviate that problem. But they never gave it a second glance.
For other reasons. Every theory that you make up has to be analyzed against all the possible consequences and to see if it predicts anything else.
Right, and your theory predicts I don't have to be accountable for anything because I'm using magical forces. I'm saying there's energy that isn't energy. Stuff moves for effectively no energy reason. There's no energy required to make the Earth move into the Sun. There's no energy required to make two magnets move into each other. Nothing has to move the stuff. It's just moved by the idea of movement.
And this predicts something else. If the Earth is moving this way, more particles will hit it from the front than from the back. If you're running in the rain, more rain hits you from the front of the face than in the back of the head, because you're running into the rain. And so as the Earth is moving in this direction, it's running into the particles, rather, and running away from the ones that are chasing it from behind. So that more particles hit it from the front than from the back, and there would be a force also sideways whenever there was any motion. This sideways force would slow the Earth up in the orbit, and it certainly would not have lasted the at least 4 billion years that it has been going around the sun. So that's the end of that theory.
So again, it really isn't the end of anything. The sideways part, I guess, is he's saying you're going to hit more stuff moving in front from sideways directions. It's hard to say exactly what he meant by that one. But regardless, the point is if there is a right-hand rule, obviously you'd be expelling as much left as right, which would be a directionality imbalance in the end, and so that would be a give and take. And you can argue, in a sense, as Zohar does, that for every action forward, there's the opposite reaction of how you have to give it back. So anything you're collecting this way, you're giving something back the opposite way. And that would compensate it. I don't think it's that simple, but because I don't think the electron and proton actually do overcome drag, so their function doesn't create enough of a machine to maintain their velocity, where atomic structures, when you put something like a neutron, which is essentially just a hydrogen atom, a small one, a compressed one, with another electron or proton, then you create a machine that can travel through space with a velocity and without being dragged to death. And there's a physical mechanism that accounts for that.
But unfortunately, he basically just decided that he'll just dismiss the entire thing just because of a small problem that came up. And this is the...
Well, let's even call it a big problem. It doesn't matter. It's one problem. So it does everything. It works really well. It's called Mach gravity. They teach it. They actually use it when they're explaining, Einstein's theory of relativity, because it creates the convergence, which they call an anti-divergence. It works really well. And so they just throw out the "it works really well" part. That's the baby, I would say. And, because there's a little bit of dirty bathwater, where they could have figured out how to wash this baby without destroying it.
Drag, or the friction problem. So I actually mentioned this in my first video on this theory, right here, orbit, which sucks. It's kind of like, there's also a lot of friction in my model. I mean, we can talk about friction in the actual universe, like moving through space. Maybe if Gary wants to talk about that.
I don't need to talk about it because I don't believe electrons are orbiting protons, so I don't think that's happening. And again, this is an elemental physical. This is gravity is a nuclear force. It's affecting the nuclear bits. That's the first thing to understand. So modeling it as suns and earths isn't getting to the physics. So I'd argue you have to model it as electrons and protons to get to the physics. And they're not orbiting, in my opinion. No evidence requiring me to believe they do that. They're in fixed magnetic positions, and the magnetism is the force being trapped between them and all of the rest. You have to account for charge. And you have to account for the fact that there's a package called an atom. It's made of parts, and that those parts can have a configuration that allows it to maintain velocity, because for every action in one side, there's a commensurate action on the other side that makes it less likely to be affected by drag. It gets more, it becomes less massive in the direction it's moving, as it moves.
But because Gary's actually the guy who's been defending this for the past 5 years, and he's actually made a response like 4 years ago to Richard Feynman, to this exact video, actually. Okay, guys, so real quick, we have to distinguish between what is matter and what isn't matter, alright? So the idea, what I'm going to say here is that basically matter is talking about a area where there's just way more force bits, okay? And the reason there's way more is probably a lot more complicated, and we're probably going to have to talk about that in future videos, because we're going to have to talk about magnetism, and there has to be a plus and a minus and all that stuff to make everything work out. For this video, we're going to just go as bare basic as we can and just talk about the criticism from Richard Feynman, okay? So
okay. So I don't know if we need to play all this. Like I said, I'll leave a link below. I agree with some, don't agree with all. And some of it's Yeah, I'd argue I don't wish to assert a final opinion, even on subjects like the existence of the fact that electrons actually move through space. That they're what's being transferred when charge is being created. When I'm kind of going to argue, I think that all that's transferred is actually the force, the pressure, and the photons. The virtual photons are exchanged, but you can't exchange the electrons because they won't play along. But anyway, those are all details that, I think the basic concept can be understood, and that's all that needs to be understood, to just recognize that their evidence is not what they claim it to be. It's not a proof. They haven't demonstrated it beyond reasonable doubt. There's lots of reasons to doubt. And the fact that there exists a perfectly viable theory that just needs completion, that does everything, and does everything in a physical way, should be a glaring concern to anybody arrogantly saying we've done it, we've accomplished it, we already know how it works. When their model isn't complete, it requires you to believe in a bunch of magical functions. It's lousy. It's a God theory. It looks like religion. It's got so many wooey parts. And you have this viable evolution theory sitting next to it, and all you're doing is going, there's no missing links, there's no missing links. Well, yeah, the non-existence of all the transitional organisms is a glaring deficit, okay, in the fossil record. But as soon as you understand punctuated equilibrium, as soon as you understand that, well, evolution mostly happens in small groups, tiny groups even, family groups, all of the American Indians, from North America all the way to the bottom of South America, are genetically related, the argument is made, to 7 females. 7. That's where the evolution takes place, is in the small groups. Big groups don't change easily. They dampen all changes. They're more likely to destroy any aberrant. But the smaller you make the group, the more likely the aberrant is to succeed. And once you understand that, well, then you understand why the fossil record doesn't have a whole bunch of intermediate fossils. It's because those small groups didn't get fossilized. They didn't get Pompeyed. They didn't have the opportunity to become a fossil because there were so few of them. So evolution happens in very small numbers, and then the small numbers, once they become a gang again, they succeed. Then they become big enough to take on the other big tribe. They become a herd themselves, and their herd dominates the other herd and wipes them out. That's how evolution really works. And once you know that, you understand, so that flaw isn't really a flaw in the theory. I can understand why. And again, they're not even trying to understand why drag might change depending on circumstances. They don't even want to give it a thought. They're just saying, no intermediate fossils, theory no good. That's all they're doing. It's right plain in your face. And you're going to sit there and obnoxiously tell me I'm a pseudoscientist, I hate science, I'm a fool, I'm an idiot. Well, then prove it with a statement. Prove it with an experiment. Prove it with some kind of evidence, except your assertion. If all you can do is make an assertion that you don't like me, you don't like what I'm saying, then you're being pathetic. You're so weak. So take the challenge up. I'll make a room for any one of you to, we can do a Skype conversation, and you can humiliate me with your great, brilliant understanding of reality. It's an open invitation to anybody who wishes to do so with some sort of reasonable discipline. And so take me up on it. You can't find one single defender of your standard model who's willing to argue it. I mean, the very fact that these videos are so easy to make, and response videos are so easy to make, how come you can't make any? with a rational argument instead of just insults. How come you can't do it? So, enough of the video. And such. So, till the next time. So forth and whatnot.
The voice-activated Izod sweater.
What temperature is it outside?
It's 28 degrees outside.
And what about tonight?
Tonight.
And what about tomorrow morning?
Tomorrow
What
morning.
about June 3rd?
June 3rd.
Izod sweater?
Yes?
Do you come in pants?
Okay. Powering off.
Izod sweaters do not talk. Yet.
The great enemy of writing isn't your own lack of talent, it's being interrupted by other people. Constant interruptions are the destruction of the imagination. In this class, you're going to be exploring your own imagination deep within you, and we're going to begin with shorter forms because short stories, short monologues, poetry, things that you can finish and show other people, that's very satisfying and necessary for a writer. What we all need is the satisfaction of this little uplift that we get psychologically from finishing something. There are two ways of looking at writing. One way is that you're telling a story very transparently. The other is that you're telling a story with language, and language is the point. How fast do you want your story to read? If it reads too fast, then it might be superficial. If a person reads it in 5 minutes, it's all over. So we're also going to be exploring your writing workshop. Writers are like cooks. They keep everything in the refrigerator and put it all in the casserole, like,
I'm having a bad week. I'm having a really
So, doing both at the same time.